Welcome everyone to the HashiCorp Terraform OSS Enterprise Advantages webinar. My name is Tom Earl and I'm going to be taking you through some of the whole of the presentation today. So I work for a company called Somerford Associates, where I'm a technical consultant and have been for nearly 20 months now. We're a HashiCorp partner with several highly skilled and qualified consultants who are trained to chip level in both Vault and Terraform. So to the presentation itself then, let's have a look at what we're going to run through today. To understand the main topic of this discussion, we're going to look into a couple of questions. What is HashiCorp Terraform? A quick reminder, revise on it and how it works, and a look into some of its features. What is HashiCorp Terraform OS? What does it offer? Once again, go through a few items so we have a basis for comparison. What is the enterprise version and how is it different to the OS version? The advantages of Terraform Enterprise, and this will be the bulk of the delivery as it's what you're here to find out today, right? We'll look over some of the features, see how they differ, see how they will benefit you and your companies when compared to the OS variant. And then finally, we'll have a summary, just to refresh what we've gone over, just in case you've missed anything. So what is HashiCorp Terraform? Well, it's a free downloadable executable file from HashiCorp, specifically from the Terraform IO website. It's a command line utility that can be compiled to run on your favorite operating system, which is very portable. It can be run from your laptop or any physical or virtual machine, or even with a container. Terraform itself is a tool for building, changing, and versioning infrastructure, both safely and efficiently. It can manage existing and popular service providers as well as custom in-house solutions. What it uses then is it uses configuration files to describe to Terraform the components needed to run single application on your entire data center. Terraform generates an execution plan describing what it will use to reach the desired state and then executes it to build a desired infrastructure. As the configuration changes, Terraform is able to determine what has changed and create incremental execution plans, which can then be applied. Terraform allows infrastructure to be expressed as code in simple human readable language called HCL, or HashiCorp configuration language. It reads configuration files and provides an execution plan of changes which are reviewed for safety and when applied and provisioned. Extensible providers allow Terraform to manage a broad range of resources, including infrastructure as service, platform as service, software as service, and hardware services. To understand Terraform, it's beneficial to look at some of its key features, those being infrastructure as code, execution plans, resource graph, and change automation. So the first one mentioned there was infrastructure as code. Infrastructure is described as using a high-level configuration syntax. What this does, it allows a blueprint of your data center to be versioned and treated as if you would any other code. Additionally, infrastructure can be shared and reused. There are 3 stages of this, which are write, plan, and apply. The write part then, this is where we write infrastructure as code using declarative configuration files. And what HCL does is it allows for concise descriptions of resources using block arguments and expressions. The next stage then is the plan. In this phase, we run a Terraform plan, and we are checking whether the execution plan for configuration matches your expectation. And then, that's prior to moving on to provisioning or changing your infrastructure. And the final stage then is the apply. And this is where we apply changes to hundreds of cloud providers with Terraform apply, and it will reach the desired state of the configuration. The next part then is the execution plans. Terraform is a planning step where it generates this execution plan. The execution plan shows what Terraform will do when you use the call apply and lets you avoid any surprises when Terraform manipulates infrastructure. Moving to the resource graph, Terraform builds a graph of your resources, and I've just mentioned it's called a resource graph, and parallelizes the creation and modification of any non-dependent resources. Due to this, Terraform builds infrastructure as efficiently as possible, and operators get insight into dependencies in their infrastructure. And then the final one here is change automation. With change automation, complex change sets can be applied to infrastructure with minimal human interaction. With the previously mentioned execution plan and resource graph, you know exactly what Terraform will change and in what order, avoiding many possible human errors. So what you may find yourself asking yourself is, if there's OS, then why would you need Enterprise? Also on the flip side, if there's Enterprise, why would you need OS? Well, that's what we're here to discuss today. Organizations adopt Terraform OS to help provision and configure their infrastructure in cloud. Enterprise provides a central way for many users within the organization to safely and efficiently provision and manage their infrastructure. It is sometimes the case that not every team has a business need for Enterprise immediately, and this is where the OS version comes into play. Open source is great for individuals or small teams, but once you get a larger team or many teams, and this is where things start to get a lot harder. If you take Terraform, where it's been used by an individual, you can often say the pattern they will adopt is they'll write some Terraform locally. They'll then conduct a plan of operation, and this is where you'll show what you're going to change, validate that the change makes sense, and then the next step will be to locally apply and make those changes. What this does then, it forms a process which is a loop, and then will be adapted to do the same again. At this level, where there are very small numbers of people, this is where the OS version of Terraform works well. Where the problem starts to occur is when things start to scale up a little, which in turn, as we all know, tends to scale up a little bit more until the OS version is being written by multiple teams in the organization. It's at this point we should start thinking about working collaboratively and also looking into version control. What this does then, it moves neatly into state file management, which is once you start to scale things up, as mentioned, you'll start to find that it's increasingly more difficult to scale and lacks collaboration features, meaning that once the demand and scale of Terraform increases, then it becomes increasingly more difficult to manage and quickly becomes complex when using OS. There's a lot of information out there that will help you determine when it makes sense to transition to the paid offering. Many individuals and small teams adopt Terraform OS to provision their clouds using infrastructure as code. As your teams expand, organizational changes arise around collaboration, security, policy, and governance. Some of the questions you may need to answer include: how will provisioning workflows be impacted when moving from an individual to multiple team members? How will teams collaborate? By this we mean users, teams, and organizations. How will teams create and manage infrastructure state? How can self-service infrastructure for developers be enabled? How do operators enforce provisioning rules and best practices from Terraform? How do administrators enforce role-based access control, or RBAC, for each of the infrastructure team? And there we're talking about network databases monitoring. And finally, how can secure cloud be enabled? If some of those questions above apply to your teams, then you should definitely consider learning more about Terraform Enterprise and how it can help you through some of the challenges that could occur from the questions I've just gone through. As the aim of the presentation is to discuss the advantages of Enterprise versus OS, and having just discussed some of the reasons and questions that you may be now thinking about, it's therefore prudent to understand what the primary features of Terraform Enterprise are compared to open source. Enterprise provides you with managed environments and dashboards that you do not have to maintain. This can be seen as one of the greatest benefits, along with collaboration and governance capabilities. In order to highlight some of the advantages of Enterprise over OS, we're going to look at the main features of Terraform Enterprise and compare it to its OS alternative. The first thing then is remotely managed. Normally, with Terraform OS, you'd run your Terraform files locally with a remote backend to something like S3. Maybe you even have a central server that you use to manage your Terraform runs. The difference between Enterprise and OS is there's nothing to manage. This can sometimes be viewed as a negative, as you'd have to go through the extra steps to set up custom abilities, such as having Terraform trigger Ansible after provisioning an EC2 instance. However, once this has all been set up, then there is very little to manage. With team management then, one possible solution for an OS environment would be to use your Active Directory to provide teams and users credentials to access the centralized server. There are many aspects of access you have to cover, from AWS Access Secure Control, also known as version control, that you don't have to worry about if you went with Enterprise. With Terraform Enterprise, the organizational access control model is split into 3 units, and those are users, teams, and organizations. Users naturally belong to a team, which are granted permissions based on organization's workspace. Organizations are shared space for teams to collaborate on workspaces. An organization owner can create teams and manage their membership. Team management is very handy and is found in every aspect of Terraform. An example of this is you can set or limit the access to variables of any type of modification and production workspace, while allowing access to a sandbox for a specific team or users. What this does then, it provides us with capabilities and ease of use not found within the OS version of Terraform. It's extremely powerful and makes life easier for management. The teams page is also shown to other users in an organization, where this is where organization owners can create and delete teams, manage team membership, and manage team API tokens. When creating a team or adding permissions to a team, it's important to understand the permission levels that have been applied. The 4 available to us are read, plan, write, and admin, where read is the lowest level and admin is the highest. What you get with this then is the rights of the lower permission are inherited by those above it. And what I mean by this is the read permissions are limited to read only rights, although the permissions above it will also have the read rights, whereas the admin will be able to delete a workspace, manage team access, run execution mode, and have access to state. No team below this permission will have access. So workspace management. Workspaces allow you to reuse the same code across multiple environments, such as a workspace for staging, a workspace for production. In both cases, you could keep the code identical, but by changing the variable inputs, you can tailor these to your liking. Enterprise offers you sleek dashboards with run statuses, providing information such as when the TF files were last modified and which repo it's wired to. This invaluable information shows allows you to see at a glance how your company grows and the repositories that are added. You've then got version control. Terraform OS provides you with repositories as normal, but the way that they manage them in OS is vastly different to Enterprise. With OS, you'll have to manually carry out the process of switching repositories, pulling the latest code, testing it out, and then applying it to production. With Enterprise, it will do all of this in a fully automated way. You'll be able to set up Enterprise with GitHub or Bitbucket, providing a fully automated testing run and testing process that will capture errors and bugs during the pull requests, and all of this before they actually enter the repository. Should you require the ability to audit and track activity within the infrastructure, let's say for compliance purposes, Enterprise will provide you with the granular history of every single workspace, so you have an understanding and insight to all changes, all activities that are happening for a given period, for a given project, given underlying Terraform configuration. Enterprise also provides a clear view of the state history, showing you everything that's happened to that state file as a result of an update to the configuration. This is taken one step further with Terraform, and once again, for compliance reasons, it can provide a very robust and granular audit log, so you can keep track of which users are accessing what workspaces or changing which configurations at what time or even from where. You'll also be able to view who is accessing, modifying, removing sensitive variables, and in addition to which users are changing or attempting to change your policy sets. All of this information is in your centralized audit log and can be used to ensure that your auditors are satisfied that you meet the requirements for compliance. You also get secure variable management, and quite simply with OS, there's no version of this out of the box. What would normally happen is that you would have your sensitive variables, you would choose to leave them out of the Terraform TFR files and leave no default in your variable TF file. When you plan, you apply your Terraform files, and you would then proceed to type in your sensitive value or include them in your environmental variables. That way, you can be sure that the sensitive value is not saved within your repository. All of this can be averted with the use of Enterprise. There are options within the workspace variable section where you can choose what variable is sensitive and what isn't. Everything else is managed for you. You also get remote runs and state. On the OS version, you store your state file in an S3 bucket and run your Terraform plan and apply the commands. It's therefore your responsibility to manage and create that state file. Worry about the version control and the status of the application of the state file. Part of the Enterprise version is that you'll be provided with a dedicated page. This page will have a history and a queue of plans that have been run by specific users, which is all transparent and self-explanatory. From here, each run will provide a deep insight into any changes or errors that may occur. It's also possible to queue new plans or runs on the fly, and the worries of version control and the management state file are no longer an issue, as this has been managed appropriately by the Enterprise solution. There's also the GUI, which makes it super simple to view the status of any run, newly committed code, and anything associated with the run, how the run was initiated, when it was run, and by whom. What you also get is there'll be a timeline of events produced along with the output of the TF plan and the apply commands. Enterprise also offers something called Concurrency Run Queueing, and what this is where Terraform Cloud uses multiple concurrent worker VMs which take jobs from a global queue of runs that are ready for processing. If the global queue has more runs than the workers can handle at once, some of them must wait until a worker becomes available. When the queue is backed up, then Terraform Cloud gives different priorities to the different kinds of runs. And three of the runs we're going to talk about there, and the priorities are applies, which will make changes to the infrastructure, have the highest priority. You have normal plans, which have the next highest priority. And then right at the bottom, you've got speculative plans, which have the lowest priority. Continuing on then with features, we've got the private module registry. And as with most products that are open source, you have a fair amount of it that you have to set yourself. The same can be said when we talk about the private module registry. It's up to you how you want to organize your modules. You can create a dedicated repo for these modules, which is the better option of unorganized modules in a variety of different repos. Obviously, there is more to the product when you have the Enterprise version. Its private module registry is extremely effective, offering the ability for it to store, the ability for it to be shared across your organization, promoting a collaborative working environment. In its registry, in addition, it will support module versioning, searching and filtering of available modules, which is similar to TF's own public transform registry. You'll be able to view each module on a dedicated page showing the inputs, outputs, dependencies, and resources that are created. Typically, each module's repo would be a private repo on something like GitHub, for example, or a hosted instance of GitLab. So that Terraform and all its features are available to clients who have air-gapped environments. Once you commit your changes to master and release it, a new version of the module will then be available. You also get a configuration designer. Using this configuration designer that you have available in an Enterprise version, you'll be able to quickly and seamlessly spin up an entire workspace using your private module registry. This provides huge benefits in creating a landing zone style deployment of environments. The process itself, it can be more simple. You essentially choose the modules that you want for your new workspace, set your variables, you can use interpolation, and at the end of the process, the designer runs a text of main TF configuration. In order to use this to create a new repo for the workspace, you'll have to copy and paste this, but in the long run, this can save you a lot of time. When we look at the OS version, sadly, the same can't be said, as you would need to manually add modules and components to your main TF file. With this, not only will it take longer, But as it's a manual and non-automated process, there is scope for mistakes to be made. We are human after all. Quite bluntly, the OS version of Terraform has no API. The Enterprise version thankfully does. It will allow you to access many of the items that you use on the dashboard through the API. This will then afford you the opportunity to create custom solutions that can integrate into Terraform Enterprise. An example of this could be that you want to onboard a user. You can have your scripts to trigger a setup to call Terraform Enterprise and add a new user to an existing team. We also have Terraform Cloud's business tier, and it has a reasonably new API service by the name of Audit Trails. It's a JSON-based API-based service that opens the ability to retrieve audit events for the entire organization. These logs, which contain anything from cost estimation to speculative plans and even Sentinel policy as code and checks of token creations. The Audit Trails API will log them and have them available for consumption if required. When we talk about consumption, I suppose this leads quite neatly onto the question of how might you consume your logs. Well, one company synonymous with data ingestion is Splunk. HashiCorp have worked with Splunk and have created the Terraform Cloud for Splunk app, which is available from Splunk base if you're interested, and is compatible with the Splunk Cloud and Splunk Enterprise versions. What this provides then, it provides the ability to work seamlessly together, and once set up, the log should start to be ingested almost immediately. What you'll be able to see then, you'll be able to see which workspaces generate the most frequent changes, which Sentinel policies are being evaluated most frequently, and which users are most active. It's packaged with several pre-configured dashboards to display some essential data tables within the Splunk interface. And of course, it also has the ability to create custom dashboards to suit your needs. The support package then, one of the greatest advantages of moving to the enterprise version is the support packages. When you use this version, the levels of support that you can get range from community all the way through to gold. The level of support will depend on subscription, obviously. Response and solution times are based on the SLA with HashiCorp, but the following severities are used when you open a ticket. So you've got severity 1, which is for all urgent stuff. You've got severity 2, which is for high level, severity 3, which is for normal, and severity 4, which is for low. Whilst you can subscribe to the support package as part of Enterprise, the only support that you have available to you with the OS version is community support, which, despite being great, it doesn't offer the benefits that the Enterprise package does. But clearly, the greater the level of the package, the higher the subscription costs. So it's a case of tailoring which level you need to suit your needs. Okay, you also get Sentinel, which is policy as code. One thing to note with this is that it requires the Terraform Enterprise Premium version. Sentinel itself then is an embedded policy as code framework integrated with HashiCorp Enterprise products. It enables fine-grained, logic-based policy decisions and can be extended to use information from external sources. Using Sentinel with Terraform Cloud involves defining policies, managing policies for organizations, enforcing policy checks and runs, and mocking Sentinel Terraform data. And the final one we've got here is cost estimation. When enabled, Terraform Cloud performs a cost estimate on every run. What this does is it allows you, it provides you rather with the estimated costs for the proposed run. It appears in the UI as an extra run phase, which is between the plan and apply phase. By default, it will show the user the estimated total monthly cost. This can be expanded to show you the itemized list of the resource costs. Don't worry if it doesn't make sense right now, but when you jump onto UI, all will be apparent. It will also show the list of unestimated resources as well. point to note right now with this is that this is just an estimate, and some of the resources may not have been in the cost estimation process, or it might have been unpredictable usage-based pricing. And this is where I revert back to Sentinel with this, as it provides a very useful tool for you to leverage in this situation. You can use Sentinel policy to validate your configuration cost estimates using the TF-run import. Cost estimation in Terraform Cloud supports Terraform resources with 3 major cloud providers, and those being the big 3, which are AWS, GCP, and Azure. As with all products, there are going to be new releases. So one thing I want to do on this presentation was to take a look at some of the new features of the latest release. You get remote state data source compatibility, and what this does, it provides a relaxed remote state data parsing requirements, meaning that practitioners can adopt new versions of Terraform into their workflows without having to immediately upgrade Terraform code bases. You get state file format stability, which provides cross-compatibility between versions, allowing customers to easily move between versions of Terraform. It also provides provider-based sensitivity and sensitive functions, which allow provider developers to protect values from being printed to console. What Terraform will do is it redact those values wherever they appear. You also get structured logging levels, which in a nutshell provides improved logging behavior, which in this modern day we value highly. So anywhere where we can look at logs, specifically audit logging, it can only be seen as a benefit. There's also unified console support. This will make a significant foundational improvement by unifying the console experience across all supported platforms. One thing I'd like to say at this point with this version is that there are some breaking changes. Notably, built-in vendor provisioners such as Chef and Puppet have been removed. List and map functions, which were previously deprecated, have now been removed. Support to all the versions of Windows is now ending. And the final one within there is the working directory must now be specified with the change directory option. So quite a lot of information there as to the benefits of using Enterprise over OS, but clearly this depends on your business needs. As you start to grow your business and you require more Terraform resource, then it's clear that you will get the greatest benefits with minimal effort using the Enterprise version. Hopefully everything I've discussed today makes sense, and all the details we've provided can make you make that informed decision whether you stay with your stay with your OS version or move on to an Enterprise version of Terraform. Nearly there, but first a little look, a little bit of information about who I work for, that being Somerford Associates, and what are the valuable services we can offer as a partner. As I mentioned at the beginning, we're CHIP certified, and we all have the public certifications as well. We're here to help you, and if we haven't seen your problem before, I'm sure HashiCorp will be very interested to hear from us on it and hopefully provide a solution or maybe a patch into a future version. As you're all here now, you're taking advantage of our complimentary workshops, which you've seen can provide you with valuable insights into new and exciting products. Also, we're more than HashiCorp partners, of course, with expertise in security and observability, to name a few spheres. Please come and talk to us. Again, we're here to help. And finally, I've included the following, should you require to read up a little bit more on what we've spoken about today. Maybe you might have missed something in the presentation as to the benefits of using Enterprise over OS. So yeah, feel free to utilize those links, have a read yourself, and once again, get in touch with us. As Somerford Associates are a HashiCorp partner, I've also included the details of our sales team that are eager to hear and help should you have any further information that you require. They'll be able to put you in touch with our CHIP certified professional consultants. Should you require further details on future events, as you may have found to get to this one, then please use the link at the bottom. I'll leave these details up for a few moments prior to ending the webinar. Many thanks for your time, and I hope to hear from you soon. Hopefully on one of our webinars with, say, something like a practical hands-on workshop, such as our quarterly HashiCorp disaster recovery enablement workshops. Goodbye, thanks for now and take care.